Good morning. Can everybody hear me? Can everybody hear me? Perfect. So let's go ahead and get started. Good morning. Welcome to class. It's good to see you guys. We are going to get started today with the integumentary system. So we're going to be talking about the skin, the functions of the skin, the different layers of the skin, what's going on at each different layer. This is a relatively short section. Stacy, I know you just came from skincare. You guys probably went a little more in depth with skin. We do have to cover the same kind of material in massage, but we don't spend a whole lot of time on it. We are going to get started today on page 106 in your Beck book. We're going to be looking again at the integumentary system, different sensory receptors, and common pathologies of the skin. So we're going to be looking from page 106 to 120. So you've got about 14 pages of material to cover. The first thing that I want to make you guys aware of is when we start looking at different organs and organ systems, we're looking at things like skeletal system or muscular system. The integumentary system is one of the notable ones because skin is the largest organ of your body. Skin is, by its dry weight, it is heavier than any other organ. It is larger than any other organ. So your skin is a very, very important organ. We call the system of the skin the integumentary system because the root word of that is integument, which means covering. So the integumentary system is the covering of the body. Now there are 6 main functions that the integumentary system provides for us. And the first and most obvious is going to be protection. Skin protects the inner parts of the body by providing a physical barrier which determines what is inside of the body from what is outside of the body. So function number 1, protection. Number 2 is heat regulation. So through the action of the skin, we are able to either increase or decrease the overall body temperature. We do this by pushing blood towards the blood vessels in the skin. Blood carries your body heat around the body, circulating, keeping everything at a nice even temperature. So if you go outside in the heat or you're exercising really hard, you'll notice that the skin kind of flushes red. That is the blood being pushed out to the surface of the body so that that excess heat gets dumped out into the atmosphere. On the other hand, if the body starts to get too cold, blood vessels will constrict. We pull blood from the surface deep into the center of the body. This is why your fingers and toes and your lips turn blue, because we've pulled blood away from those extremities, keeping the blood mostly in the core of the body, maintaining our body temperature. So heat regulation is a very, very important function of the integumentary system. The next functions are secretion and excretion. Now these 2 words mean something precise, so I want to talk about that with you guys. When we say that something is secreted, secretion is when the body produces something for a reason that is then ejected from the gland that it was produced in. Like, for example, oil glands, right? We have sebaceous glands or glands on your face that produce sebum. This is your skin oil. Skin oil serves important functions, right? It's protective, it's lubricating. So secretion is when we produce something for a reason. Excretion, on the other hand, is when we are producing and getting rid of waste products. So an example of an excretion would be sweat. Sweat will contain various waste products, whereas sebum is not a waste product. It is there for a specific reason. So there we have secretion and excretion, and the 2 glands that are doing these things. For your secretory function that produces sebum, we are looking at sebaceous glands. And for the excretion function, we are looking at sweat glands. These are called sudoriferous glands. And I like to remember this name because I think when I think of sudoriferous, I think of odoriferous. I'm like, woo, odoriferous glands. So the next function of the skin is going to be sensation. This is one of the most primary things that the human body is capable of, and it is one of the few sense organs that is fully functional as soon as you are born. Babies have very, very poor eyesight. They can't really see all that well. Everything's kind of fuzzy. You got to be real, like right in front of their face for them to be able to see you clearly. Their ears are still not fully developed, so their sense of sound is kind of muffled. They don't really have very well developed smell or taste receptors yet, but a baby's skin is fully equipped with their full sensation of touch. So firm pressure, light pressure, heat, cold, vibration, tissue distortion, their tactile sense, their touch sense, fully developed as soon as they come out of the womb. So number 4, sensation. Skin gives you sensation. Number 5 is absorption. So anyone who has gone through the skincare program understands that when we put product on the face, some of those ingredients are absorbed into the skin, like moisturizers and serums and toners. The ability of the skin to absorb is one of its remarkable qualities. It is also very useful when we are trying to administer certain kinds of medication. To give some common examples, nicotine patches, right? You put the nicotine patch on, your skin absorbs the nicotine. We use it to get people off of cigarettes. Another example is hormonal birth control. Some forms of birth control are done in patches. So you stick the patch on, you leave it on for, I don't know, a week or a month or whatever, and then you change them out. The skin will absorb certain cosmetics, drugs, chemicals through its pores, through those tiny little holes in the skin. And last but not least, another important function of the skin is the synthesis of vitamin D. Your skin will produce vitamin D all on its own when it is exposed to sunlight. So about 15 to 20 minutes of sun exposure per day is all you need, and your skin will produce all of the vitamin D that you require. Now, what is vitamin D important for? Well, among other things, it is important for a healthy immune system. It's important for healthy joints. But one of the more primary reasons that we need vitamin D is in order for your body to properly absorb calcium and phosphorus. The cells can't just take those minerals in, they have to be bound to something. In this case, that something is vitamin D. Vitamin D allows your body to absorb calcium and phosphorus, which are then going to be incorporated into your bone matrix. So vitamin D is made by the skin, but your body uses it to build and maintain strong bones. You can't just take calcium. It has to be accompanied by vitamin D. Otherwise, a lot of that calcium just goes right through you. So, and guys, calcium is also used for muscle contractions. When we get into the muscular system, we'll talk about the chemistry of a muscle contraction. The thing that is triggering or that is allowing a muscle to contract is the presence of calcium in the muscle. So vitamin D is not only important for strong bones, but your muscles require calcium in order to contract. So if you didn't have calcium, your muscles would be very weak and they would not function properly. Vitamin D is super important. So here we have the 6 functions of your skin. It serves to protect the body. It regulates your body temperature. By changing the flow of blood, we can dump extra heat if the body's overheating. This is why your skin gets puffy and red. It also secretes and excretes things like oil and sweat. It gives you a sense of touch, a sense of sensation. It can absorb certain things to a limited extent, and your skin produces vitamin D. So as you can see, the skin is a very, very important organ, and it's well worth the time and attention that we give it to study. Now, when we look at the skin overall, we generally divide the skin into, we generally identify two primary layers of the skin. Now, guys, we've got quite a bit to cover today. So if you have any questions, just unmute and shout out to me. I've got 3 of you, so we got nothing but time. When we look at the skin, we generally divide it into 2 main layers. The outermost layer is known as the epidermis. Epidermis. This word part, derm or dermo or dermis, always going to be referring to the skin. So a dermatologist is a physician that studies the skin. Dermatology, the study of the skin. So with the word part in place for skin, this prefix, this word part, epi. Epi generally is used to mean above, like above. But I want to give you guys a more subtle, a more precise translation. When you think about this word part, epi, instead of thinking above, I want you to think upon, okay? Because if I say something is above your head, you're going to be looking up here. But if I say something is upon your head, it could be over here, it could be over here. I have glasses upon my face, right? They're not above my face, they are on it. So the epidermis is the layer that is upon the dermis. The epidermis is the outermost layer. So when you look at someone's face or look at someone's skin, that is the epidermis. This is the layer that you're seeing. Now the epidermis is comprised of 5 separate layers. And we are going to go through each of those layers in just a moment. But the deeper layer, the next layer of the skin, deeper to the epidermis, is known as the dermis. Now the dermis is known as your true skin. This is skin that is vital, it is alive, there is blood flowing, there is lymph flow. All of the vital stuff of being alive is going on in the deeper layer. As you move into the epidermis, like I said, this is 5 layers up here. Some of these layers are dead, and the very outermost layer, like the layer on the very surface of the skin, is completely dead. That outermost layer, there is nothing alive. So before we get too far ahead, I want to make sure that we've caught up on highlights. At the top of page 106, the section begins saying the word integument means covering or skin. Highlight the second sentence. The skin is the largest organ of the body. The skin is the largest organ of the body. Now I want to make one little note of clarification here. The skin is the largest organ of the body. It is the largest organ that you have. The largest organ in your body. The largest internal organ is your liver. Sitting on the upper right-hand quadrant, the liver is the largest organ in the body. It is the largest internal organ. But the skin is the largest organ of them all. It is the largest organ that you have. Moving on to the functions of the skin, you're going to highlight that entire section. Save your highlighter ink. I would just highlight the numbers, 1, 2, 3, 4, 5, 6, and that just indicates to you that that entire section needs to be highlighted and you guys need to study that information. Moving on to the structure of the skin, highlight the first 2 sentences. The structure of the skin contains 2 clearly defined divisions. The epidermis, also called the cuticle or the scarf, but we're gonna stick with epidermis for our purposes, which is the outermost layer. And the dermis, also called the corium, also called the true skin. For our purposes, we will stick with dermis. This is the deeper layer that extends to form the subcutaneous layer. Subcutaneous is a word that means beneath the skin. We have a very fancy illustration at the top of page 107 looking at all of the ridiculously complicated and really packed in all the stuff that is going on in the skin. You have so much going on inside of your skin. You have tons of different sensory receptors, sweat glands, oil glands, hair follicles, you've got blood vessels, lymph vessels, tiny little muscles around each hair follicle. Those muscles contract to give you goosebumps. I mean, so much going on, so much packed into every square millimeter of skin. So we're going to start at the top, at the surface of the skin. We're going to work our way down as we start to understand the structure going on in this fascinating organ. At the top of 107, under the heading, the epidermis, we are going to highlight all of that text right there. Start highlighting. The epidermis is the outermost layer of the body and forms a protective layer covering every part of the body. It varies in thickness, being thickest on the palms of the hands and the soles of the feet. And it is thinnest on the inner sides of the limbs, so on the medial portions of your limbs. So when we say medial portion, what do I mean? I mean this area here, right? If you've ever touched this side, and I'm sure you have, if you've touched this side of your arm, this skin is very thin and delicate, whereas the skin on the palm of your hand is much thicker. The skin on the soles of your feet is even thicker still. So the epidermis will vary in thickness from place to place. It is thickest on the palms and soles. It consists of several variable layers of cells. When we say several, what we mean is 5. There are 5 layers of the epidermis. Now, different teachers will explain this to you in different ways. They will have different tricks that they use to get you to remember the different layers of the skin. And I know that we are throwing a lot of Latin words out there, but welcome to anatomy. If it ain't Latin, then it's going to be Greek. You really are learning a different language. So the 5 layers of the epidermis, they all begin with the term stratum. The word stratum is Latin. It means layer, just a layer. So each of these layers, we are giving it a particular name. Now, number 1 is stratum corneum. This is the outermost layer. So we are starting at the top, at the surface, and we are naming the layers as we move down, deeper into the skin. However, my beef with this is we are kind of going backwards in the life cycle of the skin. Skin starts out alive at the bottom, and then as skin grows and reproduces, the layers are shifted upwards towards the surface. So by the time we reach the topmost layer of skin, all these cells are dead. So rather than going Benjamin Button style, starting at the death and then moving our way backwards, I'm going to go backwards through the list. I'm going to start at number 5, which is the stratum germinativum, and then I'm going to work my way up through 4, 3, 2, and then we're going to finish talking about number 1, the stratum corneum. So bear with me, you guys. Starting at the bottom, we have stratum germinativum. Germinativum. All right, germinativum comes from a Latin word. So when we look at this root, germ or germinate, we talk about plants germinating. To germinate is to reproduce, right? To breed, to multiply. So stratum germinativum is the layer of the skin which the skin cells are dividing. This is when those cells are actually replicating themselves. So as they divide, each cell copies its genetic information and then splits in 2. the daughter cell moves downward. So we end up with 2 layers of cells over top of each other. The top layer is the parent, the bottom layer is the daughter. Now, at some point, the daughter cells will reproduce, and then they will become the parent. Their daughters will go down, the parents shift upwards. When I say upwards, I mean in a superficial direction, to the surface of the body. So if we're talking about the side, then these guys are moving out to the side. But we are always talking about moving out towards the surface of the body. So stratum germinativum is the layer in which division is taking place. Cell division is known as mitosis. M-I-T-O-S-I-S. Mitosis occurs at the base layer. Now, one more little tidbit. Welcome to anatomy. Everything has 4 different names. We just have to die mad about it. Another name for the stratum germinativum is stratum basale, B-A-S-A-L-E. This is, again, coming from a Latin word. Stratum basale means the basal layer, or like the base layer, or think basement. So the basal layer is like the basement. It is the first bottommost layer. These words are interchangeable. So we can say stratum basale, or we can say the basal layer, or we can say stratum germinativum. We are talking about the same thing. Welcome to anatomy. Everything has 20 different names. But remember, the reason why is because we source medical terms from Latin and Greek. So back in the day, there were Latin dudes over in Rome finding things out, naming them in Latin. And then there were Greek guys over here finding things out, naming them in Greek. So now we have 2 names for the same structure. And we just kept it. So as these cells divide, we said the daughter cells get pushed down, the parent cells rise up. Eventually, these parents get a little too old to reproduce, like maybe they're hitting middle age and we're just a little too old to be having more kids. They then shift into the next layer up. The next layer up is stratum spinosum. Stratum spinosum is named because it is the spiny layer. You see what we did there? Stratum spinosum varies in thickness and consists of irregularly shaped cells containing melanin. Now, melanin is the pigment that gives you a skin color. So melanin is the difference between pale Irish folks and really dark-skinned African folks. What gives skin its color is the amount of melanin that is produced. So the more melanin you have, the darker skin you have. The less melanin you produce, the fairer your skin will be. The purpose of melanin is that it absorbs sunlight, which protects these cells, which are dividing and reproducing, so their DNA is a little more exposed. It's more subject to like solar radiation. So stratum spinosum, this is where your melanin is. This layer protects the bottom layer from strong solar rays, making sure that the sunlight doesn't cause permanent skin damage or skin cancer. Now, as we move up to the next layer is stratum granulosum. This word comes from the root granule. So these cells are starting to become a little bit smaller. They're starting to become a little more shriveled looking, and they are nearing death. So the trick I like to use to remember this one, granulosum, is the granny layer. They're a little smaller, they're kind of wrinkled, and they're getting on in life, right? They're getting close to death. So we've got the granny layer, little old ladies, starting to get wrinkled, moving on with their lives, getting close to death. And When old people develop Alzheimer's, right, they start losing their memory, they will have moments where Alzheimer's patients just suddenly they wake up and they remember what's going on, and just as quickly as it came, they lost it again. But they will have moments of clarity, moments where they are aware suddenly of what is going on around them. And then those moments are fleeting, and then once it's gone, they are gone again. When we talk about having these moments of clarity, we talk about moments of lucidity. Lucid is a Latin word. It means clear. So a moment of lucidity is a moment where everything becomes clear to you. These Alzheimer's patients have moments where they suddenly understand what is happening. They remember who they are, where they are, what's going on. So as Granny gets older, she starts having moments of lucidity. This brings us to the next layer, stratum lucidum. Stratum lucidum, you cannot read that. That is too light. Hold on. I think that's a little better. Stratum lucidum. Again, lucid means clear. So just like Granny suddenly becomes clear-headed for a moment and then, loses her memory again, stratum lucidum, as these cells near the end of their lives, they become more translucent, they become more clear to the eye. So we have the clear layer, and these guys are very near death. Cells in the stratum lucidum is a nearly invisible layer of cells because those cells have all gone almost transparent. And then finally they die. And when the cells die, they shrivel up, their outer membrane becomes keratinized. It expresses a protein that causes it to become very hard and brittle. So the dried up corpses of these cells, their hardened, dead bodies, again, are pushed up to the topmost layer, which is the stratum corneum. The stratum corneum is the outermost layer. This material in the cell changes into a protein substance called keratin, which forms a waterproof covering. So if you have ever gotten wet, you notice how water does not soak into the skin like it soaks into soil. It beads and rolls off of the skin like a really good finish on your car. Keratin waterproofs the skin so that water beads and rolls off, but it is entirely composed of dead cells. These cells are all dead. They died, they dried up, and now they are flat little flakes, almost like roofing shingles covering the body. So here we have gone through the life cycle of a skin cell. It starts in stratum germinativum, born as a daughter cell. They grow, they mature, eventually they divide and push their daughter cells down. By pushing down, the parent raises up into the next level, stratum spinosum. Stratum spinosum contains the melanin, which protects you from solar radiation. This is the layer that gives you your skin color. As the spiny layer ages into a granny, we have stratum granulosum. These cells are wrinkled, they are older, they are getting nearer to death. And as old people age, they start to lose their memory, but they have moments of lucidity, bringing us to stratum lucidum, the clear layer. This is a very thin, almost transparent layer of the skin. By the time they are done in their lucid layer, the cells die, they dry out, they keratinize into dry, flaky, keratinized cells in stratum corneum. One more trick up my sleeve that I've got for you guys. A cool way of remembering the names of these orders from bottom to top, right? From newest to oldest. I'm going to write it down below. Fun little mnemonic device to remember the names of these layers of the skin. George spit gravy in Lucy's corn. Germinativum, spinosum, granulosum, lucidum, corneum. From bottom to top, George spit gravy in Lucy's corn. Okay, so before we move on, does anyone have any questions over what we have covered so far? Functions of the skin, structure of the skin, layers of the epidermis. Okie dokie, moving forward. The next layer. So just to make sure we're clear, all 5 of these layers are layers of the epidermis. All 5 of these layers are here. So now we are moving on to the next layer of the skin, the dermis. So as we move into the dermis, there are 2 layers of the epidermis. So we had 5 layers, now we have 2 layers. But before we jump into the layers, I want to talk about the structure of the dermis. First of all, the epidermis is almost a solid sheet of cells, right? It's 5 layers kind of packed in together. It's very firm and solid. The dermis, on the other hand, is a more semi-solid. It's more of a, it's not like thick layers like when you think of like lasagna. Right? If you ever made lasagna, the epidermis would be like a layer of the noodles. The dermis would be like a layer of the pasta sauce. It's more of a semi-solid. It's made up of a gel-like material called ground substance. And there are 3 kinds of fibers, of protein fibers, that are intermingled within this fluid environment, this ground substance. And those 3 fibers are collagen, elastin, and reticulin. Now let's start out with reticulin. Reticulin is a thin web-like mesh of fibers. The purpose of reticulin is to give structure. So the same way your body is built on a skeleton, reticulin is the protein that gives the general framework, right? It's a net-like thing that just establishes where everything is going to be. It works in a fine kind of branching pattern, and it helps link bundles of things. It gives these other fibers something to attach to so that they all stay in place. So if reticulin is the framework that everything is going to be built onto, collagen is the tough material that is responsible for the strength and stability of that structure. Collagen is a protein. It is known for its strength. It is very, very tough. Collagen is about 70% of the dry weight of your skin. So by far, there is more collagen than any other protein. And the final type of protein we see in the dermis is elastin. As the name implies, elastin gives the quality of elasticity. Now, this is something that a lot of people misunderstand, so I just want to make sure that we're clear on something. Elasticity does not mean that something can stretch, right? And I'll give you an example. If you've ever played with silly putty, right? Silly putty stretches, but when you let it go, it just falls down, still stretched, right? Being able to be stretched is not elasticity. That would be extensibility. Elasticity means that once it has been stretched, when you let it go, it snaps back to its original shape. That is elasticity. Don't think about silly putty, think about a rubber band, right? If I stretch out a rubber band and then I let it go, it snaps back to its original shape. That is elasticity. That is the property or the quality that elastin provides the skin. So if I take the skin of my cheek and I pull and I twist it and we see it starts to wrinkle up, when I let it go, that skin pops right back the way it was. That is the beauty of elastin. So it gives skin its resiliency. As people age, the ability of the skin to produce elastin and collagen starts to become diminished. This is why we see most of the signs of aging on the skin. The wrinkling, the sagging, like just the general loss of integrity. This is the result of the body's not being able to produce enough collagen and elastin to maintain that youthful appearance. So these are the three main proteins that we find in the skin. Please make sure you highlight the bullet points at the bottom of 107 for collagen, reticulin, and elastin. Again, I would just highlight the bullet point to give myself a mental note. The whole thing has to be highlighted, but save your ink. All right, we're going to move on to page 108. Now we are going to look at the layers of the dermis. We said earlier there were 2 layers of the dermis. The 2 layers of the dermis are the papillary layer and the reticular layer. You see those listed on page 108 with numbers 1 and 2. I want you to start by highlighting the sentence just above number 1. It says, the dermis has 2 layers, the papillary or superficial layer and the reticular layer or the deeper layer. Highlight number 1 and number 2. The papillary layer of the skin, which is directly deep to the stratum germinativum, just deep to the epidermis, contains the papillae. These are cone-like projections made of fine strands of elastic tissue that extend upward into the epidermis. Some of the capillaries contain, some of the papillae contain looped capillaries, other contain terminations of sensory nerve fibers called touch receptors. So when we look at the division of these 2 layers, we really are looking something like this, right? It is kind of a zigzagged layer between the 2, and each one of these cone-like projections up is called a papilla. So the papillary layer is this layer which contains the papilla. The next layer, number 2, is the reticular layer. The reticular layer contains fat cells, blood, lymph vessels, sweat and oil glands, hair follicles, nerve endings. This is where all the stuff of life is going to be found. So by bringing blood and nutrients here, they will eventually diffuse their way into the upper layer. They don't have much further to diffuse until they are in stratum germinativum, right, the bottommost layer. From there, these guys are on their way to death, so they don't need a lot of nutrients and stuff. They are on their way to dying. So it is the deepest layers of the skin that we need to make sure we are providing with oxygen and nutrients and waste removal. As you move upwards towards the surface, these cells are getting closer and closer to death, so we do not have to supply them with as much blood and nutrients, etc. The next thing that I want you to highlight is the last sentence of the next paragraph. So the paragraph starts with the subcutaneous tissue is regarded as a continuation of the dermis. We're going to skip down to the bottom sentence in that paragraph. Highlight fatty tissue, also called adipose tissue. So in medicine, when we talk about body fat, we use the term adipose tissue. Adipose tissue gives smoothness and contour to the body. It provides a reservoir for fuel and energy, and it serves as a protective cushion for the upper skin layers. Fat is important. It is vital for life. It is a way that we are able to store energy for when the body has to go through periods of famine, right? Remember, we evolved during a time where food was not always predictable. You had to eat when food appeared, and you could go long periods of time without food. So your body evolved to be able to store fat for a rainy day to make sure that, you know, when you had a bunch of food, if it was suddenly there in abundance, we were able to eat and store as much of it as possible. So a few weeks later, when food was not available, that stored fat was able to be burned for fuel. We were still able to burn calories if we did not have food sources available to us. So fat is extremely important. And one of the places that your body likes to store fat is subcutaneously, just under the skin. So the key things from this one that I want you to take away from this, we have two layers of the dermis, the papillary and reticular. The papillary layer contains your sensory receptors. These are your touch receptors. This is what gives you your sense of touch. The reticular layer contains the blood and the lymph vessels. Good stuff so far, everybody? Awesome. Okay, moving on to sensory receptors. There are several different sensory receptors in your skin. Each one is specially set up to detect a very particular type of stimulus. So every receptor doesn't detect everything. There are special receptors that only detect heat. There are others that only detect cold. There are some that only detect vibration. There are some that detect distortion in the tissue. So when you pinch or squeeze or twist the tissue, those sensory receptors detect that distortion. Sensory receptors are nerve endings. So these are the endings of your nerves. So we are kind of in the nervous system, but this is where the nervous system and the integumentary system become integrated. These will be located in the papillary and reticular layers of the dermis. Highlight, these nerve endings are responsible for our general senses of touch, pressure, vibration, temperature, and pain. So in the papillary zone, we have three categories of nerve receptors that we find. The first are called free nerve endings. Now we're going to highlight all of these, so just highlight the bullet point for each one. Free nerve endings are the most prevalent and the most numerous. They are sensitive to temperature differences, both hot and cold, light touch, and light pressure. So cold, heat, light touch, and pressure. A special type of free nerve ending called nociceptors are pain receptors that are sensitive to chemicals released by damaged cells. What we're getting at here is nociceptors are your pain receptors. They detect pain. The way I like to remember that name, because they detect pain. I call them nociceptors because we don't want to experience pain. So nociceptors are pain receptors. They are found throughout your body in almost every tissue, every organ, muscle, skin, bone. Interestingly, two places in your body that we do not have any pain receptors at all are in the brain and in the spinal cord. Everywhere else we find pain receptors, but the brain itself and the spinal cord do not have pain receptors, so they do not experience pain on their own. The next receptors to look at are called Meissner corpuscles. Meissner corpuscles are sensitive to vibration and light touch. So we could imagine that these are some receptors that we are really activating when we do gentle massage, like Swedish massage. And next we have Merkel discs. Merkel discs are sensitive to light touch. They are highly concentrated in the fingertips, lips, and external genitalia. So these are the things that give you a very, very fine, sensitive sense of light touch. This is why your hands and your lips are extremely sensitive. Anyone who's ever dealt with a baby knows, like, if you hand something to a baby, what's the first thing they do with it? Straight in the mouth, because this is a very sensitive area. They can get a lot of information about the shape and hardness and texture of an object by putting it in their mouth. Now, as we move from the papillary layer into the deeper reticular layer, there are two more types of receptors that we find. Highlight both of these bullet points. Ruffini corpuscles are sensitive to deep pressure and tissue distortion. So if we're doing deep tissue, we're using firm pressure. These are the nerve endings that are picking up those signals. And Pacinian corpuscles. Pacinian corpuscles are egg-shaped receptors that are found throughout the layer. They are sensitive to vibration and pressure. All right, next topic we have is nutrition and the skin. As with everything else, skin receives its nutrition through blood flow and through the lymphatic system. Capillaries are quite numerous in the skin. When we say capillary, if you're not familiar with this word, capillaries are extremely small blood vessels. So small, in fact, that red blood cells have to pass through these vessels in single file line. So when we get down to the cellular level, we are literally talking about red blood cells having to go through one at a time. These are very, very tiny blood vessels, and they are absolutely everywhere in your skin. Highlight, as much as 1/2 of your total blood volume is distributed to the skin. So what does that mean? Well, of all the blood that you have in your body, all the blood you have, half of that is in the skin. Half of the blood is located in the skin, typically. Of the remaining half, half of that is in your brain. So your brain is holding about 25% of all the blood in your body. The remaining 25% of your blood is everywhere else. All of your bones, your muscles, your vital organs, all of that is getting the remaining 25%. So skin commands a lot of nutrition, but remember, we're trying to make sure that temperature stays the same. And since your skin is the system that regulates body temperature, it makes sense that most of your blood is hanging out in the skin, because we've got to make sure that the temperature stays the same, right? We've got to maintain a consistent body temperature. Now, being massage therapists, we are very intimately familiar with the skin of our clients. Says we are one of the first lines of defense when anything on their skin starts to change. So it's important that we understand what healthy skin should look like and what is normal, what is abnormal, because if we spot anything that is really suspicious, we need to point it out to the client and recommend that they go see a dermatologist to get it checked out. In my massage career, I have had multiple clients come to me. I spotted something suspicious and I sent them to a dermatologist. Um, you know, best case scenario, I'm just being overprotective and it's really nothing. Worst case scenario, it could be skin cancer, and I may be the first one to spot it and tell them, like, dude, you need to go get this checked out because skin cancer can be deadly. And we live in Florida, so it's extremely common down here. So we must be aware of any skin condition that requires the attention of their physician. So how do you know what is healthy skin? How do we know what skin should look like? At the bottom of page 109 under healthy skin, I want you to highlight the first sentence. Healthy skin is slightly moist, soft, flexible, and slightly acidic. All right, moving on to the next page, we're on page 110. There are appendages of the skin that are generally we're talking about glands or hair follicles, things that are associated with the skin. The first two we're going to look at are those glands that we mentioned earlier, the sebaceous glands and the sudoriferous glands. Sebaceous glands produce sebum, that's where they get their name, and they connect hair follicles to the surface. They produce sebum, which is then secreted. Sebum lubricates and moisturizes the skin. So sebum is your normal skin oil. If you like take your finger and rub the side of your nose, you'll notice it's kind of oily. That is sebum. It is secreted from sebaceous glands. It is there for a reason. It lubricates, protects, moistens. The next glands are, hold on, I'm sorry. Under sebaceous glands, I want you to highlight the first two sentences. Sebaceous glands connect to the hair follicles and produce sebum, which when secreted, lubricates and moisturizes the skin. Sweat glands are under the control of the autonomic nervous system and are located in the dermis. So guys, when we talk about autonomic nervous system, just translate that word in your head. Autonomic means automatic. It's the part of the brain that controls all the stuff that you don't have control over, right? You don't tell your heart when to beat. You don't tell your skin when to sweat. You don't trigger your body to run a fever. Like your brain just handles all that kind of in the background. That is the autonomic nervous system. So your sweat glands are under the control of this automatic system. I do not have control over when I sweat. Next section is the sudoriferous glands, or as I like to call them, the odoriferous glands. These respond to elevated body temperature from environmental conditions or physical activity. So when you walk outside, and we live in Florida and it's the summer, and you walk outside and you are immediately drenched in sweat. That is the sudoriferous glands. Sweating is an important process. It helps you regulate body temperature by producing moisture on the surface of the skin. The heat outside will evaporate that moisture. The evaporation pulls a little bit of heat with it, leaving the skin cooler. All right. The next thing we're going to talk about, other appendages of the integumentary system, are the hair and nails. Yeah, as weird as it is to think about, hair and nails are appendages of the skin. Highlight, Hair and nails are appendages of the skin. They are composed of hard keratin. Yes, the same keratin that we saw in the outermost layer of our skin in the stratum corneum. We said those cells were dead. They had become keratinized. The same protein, keratin, can be put together in a couple of different ways. Generally, we have what we call hard keratin and soft keratin. Soft keratin is found in the skin. Hard keratin can come, again, in two different shapes. It can either be extruded in long strings, or it can be extruded in flat sheets. Strings of keratin form your hair. Sheets of keratin form your fingernails. Hard keratin has a lower moisture and fat content. It is a particularly tough, elastic material. Highlight: hard keratin forms continuous sheets like fingernails or long fibers like hair. So hair grows all over the body with certain notable exceptions like the palms of the hands, soles of the feet. But the amount of hair that a person has is generally due to genetic factors. So if you've ever gone to the beach and seen guys, some guys have like no chest hair at all. Other guys have like a chest full of hair and arms, and they've got back hair. The production of hair is generally genetic. The texture of the hair, whether the hair is straight or wavy or curly, has to do with the shape of the follicle. So if the follicle is more round, the hair will be straight. If it is kind of more oval shaped, you may have like wavy hair. And if it's really kind of pinched, like a strong oval shape, that hair will be very curly. But that's not important. That's just fun fact. The texture of your hair is based on the shape of the hair follicle. All right. The next thing I do want to talk about, we are going to go to the top of page 111. You've got a couple of diagrams, and then right when the text starts, I want you to start highlighting. It says, associated with hair follicles are sebaceous or oil glands and erector pili muscles. The erector pili muscles are fan-like muscles that are connected to the base of the hair follicle, and they are positioned in such a way that they contract in reaction to cold or emotional stimuli. So the base of the hair follicle is connected to this muscle. And when the muscle contracts or shortens, it pulls the base of the hair follicle upwards toward the surface of the skin. This causes the entire hair shaft to rise up. So the area of skin where that hair follicle sticks out, that area of skin tends to rise up as the hair is lifted in place. That is a goosebump. We are talking about goosebumps here. Erector pili muscles are the muscles that cause goosebumps. They are triggered by temperature changes, especially cold, or emotional stimuli. This is why when you get scared, you get the chill up your neck, or you get nervous and you start getting goosebumps. These erector pili muscles are very important. All right. So this is everything that we need to talk about in terms of the way the skin should be. As we learn anatomy, we go through each organ system. We start out by learning what the system should be doing. What is going on when the system is working properly? You learn a lot about the way it works by watching how it fails. So the last thing that we will usually talk about are the disorders or the pathologies of that organ system. So everything that we have learned so far is assuming that everything is working according to plan, right? The skin is healthy, we've got all the layers working properly, we've got all the nutrients that we need, and there has been no disease or pathology or trauma to the skin. When we say trauma, we mean some kind of external injury, right? Like a fall or a car accident. Pathology is a disease. It's a disorder that arises because of a malfunction in the tissue. Now, pathology could be the result of an infection, or it could be a genetic issue. But generally, when we talk about something going wrong, it will fall into one of two categories. It will either be trauma or pathology. What we are going to be looking at next are the disorders of the skin. Before we jump into that, I want to open it up one more time. Do we have any questions over anything that we have gone over so far? We have covered functions of the skin, layers of the epidermis, layers of the dermis. We talked about sensory receptors and the appendages of the skin. Any questions over what we've done so far? Ralph, Mandy, we're good?
Yeah, I'm good. I'm good. Everything's good so far.
Okay. So the next thing we're going to look at are lesions of the skin. A lesion is a structural change caused by injury or disease. Thank you, Mandy. Thank you. All good. All right, so structural changes to the skin caused by disease or by trauma, these are called lesions. Now, some of these are going to be a little more, Ralph says on. Thank you, guys. Ralph and Mandy, thank you. Okay, so when we look at disorders of the skin, the first thing we're going to look at are blackheads. These are not dangerous. Blackheads are small masses of hardened, discolored sebum, frequently on the face, chest, shoulders, back. Generally what happens with blackheads, so here we've got the surface of the skin and we have a pore, but remember we've got sebum being produced. Sebum kind of washes over the top layer of the skin. It can get trapped in the pores, blocking the pore. Oh, this marker sucks, I'm sorry. This marker, I can barely see that. This marker sucks too. I think people are like leaving my markers with the lids off. I think that's what's going on. These are all drying up. Guys, give me like 5 seconds. I'm gonna run to the classroom next door and grab a fresh marker and I'll be right back, all right? Just sit tight. All right, I grabbed 2, so one of these should work. That's better. All right, so the sebum washes into the pore, it gets stuck there. And then what happens is the top portion of that sebum, because it's exposed to oxygen, it oxidizes. That oxidization changes its color. So the top portion of it becomes darker. So we end up with kind of a darkened little plug. Blackheads, when you extract them, they pop out. And if you're not really grossed out by this kind of thing, like I have a skincare license, I love extractions. I find it deeply satisfying to be pulling stuff out of people's skin. But if you extract a blackhead and then you look at it up close, what you're gonna see is just a hardened mass, and the tip of it is gonna have like a dark gray or kind of a blackish plug. This is where it became oxidized. So blackheads are also called comedones. This is the technical name for a blackhead. So if you see a skincare product and it says on the label it is non-comedogenic, What it means is this product will not block your pores. It will not create blackheads. Non-comedogenic is non-blackhead producing. Now, there are obviously a lot of different things that could be going wrong with the skin. The easiest way is to start on the table on the next page where it actually gives you photos to look at, like really good pictures. So we'll start at the top. We're going to look at a bulla. Under the word bulla, just make yourself a note. Guys, it's a blister. A bulla is a blister. There is a fluid-filled cavity under the skin. So you have an enclosed, raised portion of skin full of fluid. Think second-degree burn. Think a really bad sunburn. Think you wear heels when they're brand new, you haven't broken them in, and now you've got blisters on the back of your ankle. That is a bulla. The next one we have are cysts. If you've never had a cyst, they can be quite painful. This is a very firm, very hard lump or nodule. Nodule is the medical term. We're talking about a lump. But a cyst is a very firm lump or nodule located under the skin. It usually causes the skin to protrude. But when you run your finger over it, you can feel it's a solid lump and it kind of slides side to side as you run your finger over it. This could be something like acne, like cystic acne. You're talking about a very deeply infected pore. This could also be something like a lipoma, which is just a fat tumor. They're harmless. They're kind of ugly to look at, but they don't cause any real damage. Or it could be like a sebaceous cyst. Certain oil glands will develop cysts over time, and usually the treatment for cysts is you have to lance it, you have to cut it open and then pull the thing out and then close up the wound. That is a dermatologist thing. That is not a massage therapist thing. We just need to understand what cysts are. A macule is just a discoloration. So it is still even with the rest of the skin. It is just an area that has become discolored. So if you've ever seen old people and they get like those liver spots on their face or on their hands, that is a macule. Another example of a macule is a freckle. So I got like one there. I don't have a whole lot of freckles. I have a couple on my arms, which you can't really see, but like there's one. That's a macule, just a little dot. And when you run your finger over it, it's perfectly level with the rest of the skin. For my skincare peeps, hyperpigmentation would be another example. It's a macule, an area of discoloration. Now, the next three down this list, we are going to highlight these. A papule is a small elevation of the skin. It is usually red, but it doesn't have a head on it. It's just a red bump. This would be like a pimple that's about to come up, but it's not quite there yet. So you would see things like acne or warts. It is a small elevation of the skin, but it does not contain any fluid. So you can sit there and dig at it and dig at it. You're not going to get anything out of it. A pustule, on the other hand, is full of fluid. We call it a pustule because it's full of pus. Think a pimple. A pimple or a zit, that is a pustule. It is an elevated bump. It usually has a white head on the top of it. This is will be differently colored. And when you pop it open, it's going to be full of pus, like a greenish or a yellowish or whitish colored thick fluid. It will be raised. It will be inflamed. So it'll be red, swollen, warmer than the surrounding skin to the touch. We're talking about pimples. We're talking about acne, impetigo, folliculitis. There are a lot of different things that could cause these things. The next one we have is a tumor. Now, when you hear the word tumor, guys, we're almost always talking about cancer. Common cancers of the skin include melanoma and basal cell carcinoma. We'll talk about those in a minute. But a tumor is an external swelling. Any type of abnormal mass, not necessarily cancer, but if you see a tumor, they need to go see a physician because you can't tell different types of cancers apart just by looking at them. They have to do a biopsy where they take a sample of it, send it to a laboratory, they look at it under a microscope, they run certain tests on it to determine exactly what kind of tumor it is. Many tumors are harmless. They appear and they stay there and they never cause any problems. Other tumors can begin to spread, and if they spread too far, it can really cause a lot of damage. That would be like malignant cancer. Okay. Next up, we're going to look at a vesicle. This is one I want you to highlight. A vesicle is a small blister containing clear fluid, usually just beneath the epidermis. Think about a poison ivy rash or a poison oak rash. We're talking about very small water-filled blisters. Now, you may be asking yourself, self? And you would say, huh? Didn't we just say blisters containing fluid? Weren't those called a bulla? Yes, the difference in these two is the size. A bulla is a large blister. A vesicle is a very small blister. Usually vesicles happen with a bunch of them at once, right? So if you've ever had poison ivy, you may have dozens of tiny little water-filled blisters. With a bulla, these are larger. Usually you only have one or two, right? So if you think about like a really, really bad sunburn, you'll have a couple of very large blisters. Those would be bullas, but dozens of little teeny tiny blisters, those are vesicles. I know that it sounds like everything has a different name in medicine. It does, because we have to be very technical and very precise about what we're talking about. So yes, everything in medicine has like 5 different names, and everything has a name to begin with. And it's just one of those things, guys, we just have to die mad about it. It just is what it is. The last one on this list is called a wheal. I know it sounds just like wheel, but this is just a red elevated bit of skin. It's very itchy. Think about a mosquito bite. I know you've had a mosquito bite before, and it itches and itches and itches, and then you look at it and it's just a small raised red bump. No water blisters, right? No breaking of the skin. There's no pus or anything like that. It's just red and inflamed. A mosquito bite is an example of a wheal. If you've also ever broken out in hives or seen someone break out in hives, those are also wheals. Same thing. Now, those are the primary skin lesions. When we say primary, we mean this is the problem. Secondary skin lesions are usually things that happen as a result of primaries or because you kept picking at it, right? You kept scratching it and you damaged the skin further. Now you've created a secondary lesion. It is secondary to the primary lesion, the thing that you are scratching. And the first one we're going to look at is a crust. A crust is exactly what it sounds like. There was a fluid that was oozing out of the skin. It is dried and hardened into a crust. This would be like a scab, right? So scabs are dried red blood cells, plasma, and platelets that dry. They form the scab to seal the injury from the outside world. That is an example of a crust. And I know your parents always told you not to pick your scabs. The reason is because it is sealing the injured area from the outside world. Remember, the first function of the skin is protection. When you open the skin, you are open to invaders. Bad guys can get in the body. A scab is a temporary seal that closes that injury, preventing further infection. If you go picking at the scab, then you're opening the skin up to infection. So leave those scabs alone. An excoriation is an abrasion produced by scratching or scraping. So if you've ever had a rash or something and you're scratching, and eventually the skin becomes kind of red and kind of raw, that is an excoriation. We could be looking at nail cuticle damage from biting your nails, like you bite and now it's all like peeling and torn. This could also be like a raw surface, like if you fell on a bike, right? You got a little bit of a road rash. That would also be an excoriation. The next one I want you to highlight is a fissure. The word fissure means crack. So it's a crack in the skin. If you've ever seen somebody who has dry, cracked heels on their feet, those are fissures. If you've ever busted your lip, right? Like during winter time, when the skin of your lips get really cold and chapped and they crack open, that is a fissure. Next, we have a scale. So for your skin to develop scales, we're talking about thick flakes of keratinized skin that usually come off in sheets. So it really does like come off like in little flakes. Think about dandruff, right? If you've ever had dandruff or seen someone with dandruff, like you scratch your head and then there's that little snowfall of flakes. This is why you can't wear black, because all your little hair flakes start showing up on your shoulders. Another example is psoriasis. Psoriasis is a skin condition that causes extremely red, dry, irritated skin, which then flakes off. So those are scales. A scar is a slightly raised or depressed area where the skin sustained some kind of damage and it healed, but it didn't heal with skin tissue, it healed with scar tissue, is what the body does. Now, scar tissue is amazing, but it is not skin, right? Whatever part of the body you damage heals with scar tissue. It does not heal with whatever kind of tissue was damaged. This means that areas that have suffered damage often will lose part of their natural ability. So when we talk about skin being flexible and supple, yes, skin is flexible and supple, but scar tissue is mostly collagen. Collagen is not super flexible, it's more for strength. So anytime that your body heals with scar tissue, we are losing a little bit of the natural ability of that area. The medical term for a scar is a cicatrix, C-I-C-A-T-R-I-X. A cicatrix could be very small. I know a lot of people like fall when they're kids and bust their eyebrow and now they're left with like a little scar in their eyebrow. Think like Jason Momoa has one, a little scar on his eyebrow. Other people could have huge scars, usually for like surgeries or something. People who have had heart surgery often have, a scar like this long. It's a thick, dense, really protruding scar. My mom had abdominal surgery. They cut her from the bottom of her rib cage all the way down to her pubic bone. Like her entire abdomen was opened up. So medical term for a scar, cicatrix. A stain on the skin, we're usually talking about something like a birthmark. Stains are generally not harmful at all. You're just seeing a discoloration. One of the more famous examples is called a port wine stain. Port wine stains are a purplish blotch. You're born with them. It's a type of birthmark. If I don't know how old you guys are, but if you're old enough to remember the 80s, when the United States was in a Cold War with Russia and President Reagan met with, or I'm sorry, Germany. I'm talking about Gorbachev, Mikhail Gorbachev. He was the Russian ambassador. He famously had this huge purple birthmark like on his face. Let me see if I can find a picture of him real quick. I'll share my screen with you guys. Okay, I found one, so let me share my screen real quick with you guys. Can you guys see my screen? Am I sharing it? Perfect. So there you can see the port wine stain. This guy was famous for it. But this is harmless, right? It's a birthmark. It's harmless. It's not cancer. It won't cause anything. But it is, I guess we'd say, unsightly. So abnormal discolorations can appear after the removal of a mole. So you remove a mole and that little spot will be a little bit lighter than the remaining area. We could be talking about freckles or liver spots. Sometimes they're just present from birth. Now, the last one we're going to look at on this list is an ulcer, and I do want you to highlight ulcer. This is an open lesion of the skin, so it is open. You can see like the wet, fleshy inside, but it is accompanied by a loss of skin depth. This is one of the key features of an ulcer, right? Not only is there an open wound, but the skin kind of is depressed right along that area. It's sunken in. This requires medical referral, especially in clients with other underlying medical conditions. These ulcers need to be treated because they are an open wound and they're prone to infection. Usually ulcers are caused by infection, but you could always have multiple infections going on at the same time. So. All right. So I only have a few more that I want to talk about, and then we've made it through the entire section. We're going to move ahead to the next page. We're on page 116. I have one highlight for you on this page, and it is, if you go down in the margin, you'll see the term basal cell carcinoma. Now slide over into the text. I want you to highlight that first sentence there. It says, basal cell carcinoma, highlight, the least malignant and most common type of skin cancer is basal cell carcinoma. By least malignant, we mean it doesn't really spread very often. If it does spread, it doesn't spread that far. So the least malignant, the least likely to spread, and the most common is basal cell carcinoma. So basically, if you must be diagnosed with skin cancer, this is the kind you'll want. It's not that bad, it's easily treated. Now we're gonna move over to the next page, page 117. And in the text, you will see the section marked malignant melanoma. I do want you to highlight the first sentence there. Malignant melanoma is the most serious, but the least common. So you don't see it as often, but malignant melanoma is pretty bad. It is lethal. It can kill you if it is not treated within, in time. So the trick with malignant melanoma is identifying it quickly and getting treatment promptly. There are a few things that we can use to help identify malignant melanoma. We call them the ABCs of malignant melanoma. These are listed in the box at the bottom of page 117. So the ABCs of malignant melanoma, A is for asymmetry. If the lesion is asymmetrical, right, meaning it is not perfectly round or oval, right, there should be somewhere you can draw a line through it and it's symmetrical on both sides. Malignant melanomal blotches are not symmetrical. It's just a random blotch. The second thing is borders. You want to see clearly defined borders. If you don't, if the borders are fuzzy, that is a bad sign. If they're notched or indistinct, you want to see very sharp, clean borders. Color. You want to see one uniform color throughout the mole or throughout the lesion. Malignant melanoma, often you will see multiple colors going on at once, like you'll have some blacks, you'll have some browns, you'll have some redness in the tissue. Color that is widely variable is generally a bad sign. Next thing is the diameter. Anything larger than the diameter of a pencil eraser, so you're looking at about 1/4 of an inch or so, smaller than that is fine. Larger than the diameter of a pencil eraser is a red flag. This is not something that is normal. And the last thing, your book says evolution, meaning you notice that it changes over time. It may be getting larger, it may be changing colors, maybe the borders are changing over time. Normal, healthy moles should not be changing. They should stay exactly the same. So if you do notice any change in the size, shape, color, but another alternative that I will tell you, E stands for elevation. Moles or things, if one of the things that you're looking for is it elevated over skin surface? Most freckles and things sit at skin level. They are flush with the skin. So there you have your ABCs of malignant melanoma: asymmetry, borders, color, diameter, and evolution or elevation. All right, the last thing that I want to go over with you guys, we're going to move on to the next page, page 118. And there are many different types of allergies that people could have with their skin. We have things like dermatitis, we have things like eczema, but the one that I want to talk to you guys about is more common in the massage world because we are applying oils and lotions and creams and gels and stuff to people's skin. The one that I want you to highlight is at the very bottom of page 118 under contact dermatitis. You're going to highlight that whole small paragraph. I think it's like 4 whole lines. Highlight contact dermatitis refers to abnormal conditions resulting from contact with chemicals or other exterior agents. Some people develop allergies to ingredients and some substances with which they work. For instance, when a cosmetologist becomes allergic to hair tints. This is a very common thing. Allergies can develop over time. You may go your whole life not allergic to anything, and then all of a sudden you have an allergic reaction to peanuts. Allergies can develop. With contact dermatitis, we are talking about a specific type of skin irritation that develops as a result of contact with that external substance. One of my friends is a licensed nail technician. She does really good nails, but she gets contact dermatitis whenever she touches acrylic powder. If you guys don't do nails, acrylics are put on by mixing a powder with a liquid, but that powder is super, super fine. It's an extremely fine white powder, almost like a dust. And once you open that bottle, it goes everywhere and it settles on everything. And any part of her skin that acrylic powder touches, her skin just flares up. It gets red and blotchy and itchy. There is no cure for contact dermatitis. You could usually use some kind of antihistamine like Benadryl or something like that. But the only way to fully prevent it is to fully prevent contact with whatever substance triggers the dermatitis. So, guys, I know that we skipped over a lot. I do want to remind you guys that it is important that you read everything. I am giving you the highlights. I am talking you through key points. But this is a full day's worth of work, so I do expect that you guys read the entire chapter. Make sure that you guys are completing all of the activities on MindTap, all of the readings, all of the quizzes, all of the activities. You guys have to do everything. That wraps us up for the integumentary system. So I would like to open this up one last time. Do we have any questions or anything else that you guys would like me to go over or touch back on before we call this meeting for today?
Oh, good. Thank you.
Ralph, you're good. Thank you, sir. Mandy, Stacy, any questions?
I'm good. Thank you.
right, Mandy, thank you very much. Stacy, you good? Stacy's good. All right. Later on this afternoon, this lecture should be recorded and posted onto MindTap. And as you can see, we are now in Zoom instead of GoToMeeting. So hopefully we'll actually be able to get some video moving forward. I don't know why GoToMeeting was not recording my videos. It was just my audio. So hopefully this fixed the problem. As always, if you guys have any questions or concerns, shoot me an email, shoot me a text, reach out to me. I'm here to help. And until next time, you guys enjoy your Monday, and I will see you guys on Wednesday.